Okay, so this might not be the best view of how to do addition, subtraction, multiplication, and division. But since I can't get the video to work, I'm going to share it with you this way. So for starters, if we're looking at addition is our baseline of what we want to know. Let's see here. So if we're going to add, we could put a 2 plus 3 on top of each other. We get 5. That's a basic addition fact. Well, if we switch that up just a little bit and say we have 15 plus 7. Okay, this is going to be greater than 10 if we start on the right. So we have 7 plus 5. We have 7, 8, 9, 10, 11, 12. We put our 2 down. We carry our 1. 1 plus 1 is 2. So that's an example of a 2-digit and a 1-digit addition problem. So then if we take a look at, say, 27 plus 34. So we have a 2-digit by 2-digit addition problem. We have 7 plus 4, so we have 7, 8, 9, 10, and 11. We put our 1 down. We carry a 1. We have 3 plus 2 plus 1 would be 6. So our sum for this, or the answer to this addition problem, would be 61. Now if we take a look at subtraction, the number on top always has to be greater than the number on bottom. So 8 is greater than 3. So we have 8 minus 3. That would be 5. If we tried 17 minus 4, we start on the right. 7 minus 4, 7, 6, 5, 4, 3. And you bring down that 1. There's nothing underneath there beside that 4, so we just act like it's a 0. So there's 13. Now, if you get to a double-digit subtraction problem, you might have 57 minus 38. And I purposely made this bigger than that 1's place on top, which is that 7. So we have 7 minus 8. We can't do that because 7 is not greater than 8. So what we have to do in this problem is we mark out this 7, and it turns to a 17, and we borrow from the neighbor. So we have 17 minus 8, so we have 17, 16, 15, 14, 13, 12, 11, 10, 9, 8. So we know that 9 plus 8 would be 17, so our difference here would be 9. And then we have 4 minus 3, which is 1. So the difference for this problem would be 19. So again, we're borrowing. You can't ever have a number like 27 over 54. It doesn't work that way. Yes, 7 is greater than 4, but 27 is not greater than 54. So you can't do that problem. Now you could do 54 minus 27, but we can't do it the other way, okay? And I'll do this one as an example. So we have a 4, it changes to a 14, 14, and then this changes to a 4. So 14 minus 7 is 7. 4 minus 2 is 2. That's kind of cool. Those were both half of what they normally are. I didn't even think about that. So our difference is 27 here. So we have addition, we have subtraction. So we look at multiplication. If we're looking at our basic facts, we have 7 times 5. We know that's 35. You just write it down like normal. If you have 12 times 6, this is a double digit by a single digit. 6 times 2 is 12. You put your 2 down, carry your 1. 6 times 1 is 6, plus 1 is 7. So the product, which is the answer to a multiplication problem, would be 72. Let's try this. 13 times 54. This is going to be a big one. So when we're multiplying, we start on the right. We go up first. So 4 times 3 is 12. Put your 2 down. Carry your 1. Then you go across. So 4 times 1 is 4. Plus 1 is 5. We have to mark out what we carried in that 1's place. And you always have to put our placeholder. If we don't put that placeholder, the whole problem can totally be destroyed. Now we go from the left to the right. So 5 times 3 is 15. We put a 5 down. I carry our 1. 5 times 1 is 5, plus 1 is 6. And we're going to be adding because we're multiplying. So now we work from the right to the left. We have 2 plus 0, which would be 2. 5 plus 5 is 10. Now that's a great number greater than 10. We can't put that down here, so we just put our 0 down, carry our 1. Then 6 plus 1 is 7. So our answer for 13 times 54 is 702. And I'm going to scoot this up just a little bit, and I'm going to do a few division problems. So we're looking at division. Anytime we're getting larger, we'd use addition and multiplication. If we're getting smaller, it's going to be division or subtraction. I think I said that right. So addition and multiplication get larger, subtraction and division get smaller. So we take a look at this. We have 7 divided by 56. Let me do 2 divided by 6, and then I'll do one over here. Let's say 1754 divided by, let's do 8. Who knows what that will come out to be, but we'll see. So if I look at this first one, I want to look at 6 divided by 2 first. The first question you have to ask yourself every single time, it's a golden question. How many times can 2 go into 6? Or at least get me close. So I know that 2 times 3 is 6. So I put a 3 up top. This is called long division. There's a bunch of different ways they say that, but essentially it's long division. It's just been a little modified over time. So we put that 3 up top. 3 times 2 is 6. And we subtract. So we have 6 minus 6 is 0. Now this gave us an even answer. There's no remainder. It's just a clean cut answer. So that's a basic division problem. Now we take a look at 56 divided by 7. This is a little bit tougher because you notice we ask ourselves, how many times can 7 go into 5? We work one place at a time from the left to the right. So 7 can't go into 5. So I put a 0. 0 times 7 is not 7. It is 0. We subtract. 5 minus 0 is 5. And I bring down my 6. Now I ask myself that golden question. How many times can 7 go into 56? This one happens to be even. So I know that 8 times 7 is 56. So I put an 8 here. 8 times 7 is 56. I'm going to subtract. 6 minus 6 is 0. 5 minus 5 is 0. So again, much like this one, we have a clean cut answer with no remainder. Now this next one, I don't know if there will be a remainder or not, but if not, I'll just do another problem. So we have 8, and then inside the little house is 1,754. So 1,754 divided by 8. I ask myself, how many times can 8 go into 1? That is a 0. So 0 times 8 is 0. We subtract. 1 minus 0 is 1. You bring down its neighbor of 7. So now I say, okay, how many times can 8 go into 17? Or at least get me really close without going over. Well, I know that 8 times 4 is 32. That's too big. 8 times 3 is 24. That's still too big. How about 8 times 2? 8 times 2. So 2 times 8 is 16. So I'm going to write 16 here. And I'm going to subtract. 7 minus 6 is 1. 1 minus 1 is 0. Now I bring down this 5. So it turns into 15. Now I say, okay, how many times does 8 go into 15? Well, I know it's not 2. I just did that. So it's only once. 1 times 8 is 8. I'm going to subtract again. Now, this one we're going to have to borrow. So we make this a 15. This changes to 0. So what is 15 minus 8? So we have 15, 14, 13, 12, 11, 10, 9, 8, 7. So my answer here is 7. And now I bring down that 4. So I ask myself, how many times does 8 go into 74? Well, I know that 9 times 8 is 72. That's as close as I can get. So then I subtract again. 4 minus 2 is 2. 7 minus 0 is 0. So what we have here is a remainder. There's no other numbers to go through. So we have to stop here. What we do is we put a R2. That means that 1,754 can be divided by 8 219 times with a remainder of 2. It's going to have 2 left over. Just one of those things, they're basically extras, but they call it a fancy word named remainders. So that's a basic review of your addition, subtraction, multiplication, and division. They build on each other, so we got to get that addition and subtraction done first before we understand how to do multiplication and division.